Morning, Teffo. Today's kind of a sad day because it's our last day together, but you and I will still see each other and speak some more in some other future circumstances. Okay, so let's go through this last question, number 1, and then we can put an end on this revision. Today's one is going to go by a little bit faster, I promise you. It's not going to be an hour long. Right, so for question number 1, yet again we've got 3 sets of equations that will try to test different things. Okay, so let's go. Question 1.1.1, right, we have x squared plus 9x plus 14 is equals to 0. Right, we've got a nice form of the trinomial over here. We've got all of our terms present, right? So chances are we are just going to factorize this quite nicely into 2 brackets. Let's see. Okay, so we have a is equals to 1 in this trinomial, so we can just put an x and an x. Okay, let's look at the factors of 14. We've got 1 times 14. We have 2 times 7. Okay, we can make a 9 using 7 and 2. 7 plus 2 is 9, right? We just need a plus sign over here, so it's very simple. It's just going to be plus 2 and plus 7. Okay, 1.1.2. Right. So now this instruction over here, whenever you see this, correct to 2 decimal places, right? You can immediately just know that this trinomial over here is different from the one above in terms of the fact that this one doesn't have rational number solution. So you can just immediately go into your quadratic formula in order to solve this one. Okay, so we have 4x squared plus 9x minus 3 is equals to 0. Okay, let's identify our a, b, and c values. Right, so there's a, that's 4. B is 9. And C is minus 3. So then straight from there, you're just going to say, therefore, x is equals to minus b. I'm just going to start substituting, right? So minus b is minus 9, plus or minus the square root of b squared, minus 4 times a is also 4, times c. All of this must be divided by 2 times a. Okay, so we're going to have x is equals to, or x is equals to, let's grab a calculator. So they wanted the answer correct to 2 decimal places, so we're not going to write it in surd form, right? We're going to press this little button over here that says SD, right? So this actually means surd to decimal, right? So you're going to click on that, and you get that your first answer is going to be 0.29. Okay, so correct to 2 decimal places. That 4 won't round the 9 up, so it's just 0.29. Let's check the other solution. Okay, and we have negative 2.54. Okay, so for our first solution is 0.29, and the other one is negative 2.54. Okay, there we go. Question 1.1.3, right? We need to solve for x. We have the square root of x squared minus 5 is equals to 2 times the square root of x. Okay. So for this one, the only really extra step that we're going to have is to test our x values, right? And make sure that when we substitute them back into this original equation, we don't get a negative underneath the square root, and also obviously checking that the left hand side is equal to the right hand side. Okay, so let's go. So our next step is going to be to square both sides, right? So we have x squared minus 5 is equals to 2 times the root of x. So what we're going to do is we're going to square both sides. Okay, now on this side, this square is going to distribute both to the 2 and to the square root of x. Okay. On the left hand side, the square root and the square is just going to cancel each other out. Okay, leaving us with x squared minus 5 must equal 4 times x. Okay, now what we have now is a trinomial, right? Take this 4x, move it to the left hand side, right? Set it equals to 0. Okay, so we're going to have x squared minus 4x minus 5 is equals to 0. Okay, for this one, I can already see we can use 5 and 1. Okay, let's see. If you have a negative 5 plus 1 will give you a negative 4. Negative 5 times a positive 1 is a negative 5, so that's going to be fine. So we're going to have x plus 1, x minus 5, and this is equals to 0. Let me just check it quickly. Negative 5, positive 1, negative 4. Positive times negative is a negative. Okay, cool. That's fine. Right. So then we have that therefore x plus 1 is equals to 0, or x minus 5 must equal to 0. Okay. So we're going to have that therefore x is equals to negative 1, or x is equals to positive 5. Okay. Okay, so that's our two solutions. Okay, before I underline them, let's just check them. Right. So we have a left hand side, right, which is equals to the square root of x squared minus 5, right, and we want to check when x is equals to negative 1, right. So when x is equals to negative 1, we'll be dealing with the square root of negative 1 squared minus 5, right. So negative 1 squared is going to be a positive 1, right. A positive 1 minus 5 will give us a negative 4 underneath this, right. So this is going to be less than 0, right. So then therefore x is equals to minus 1 is not a solution, right. So not a solution. Okay, so what we can do here at x is equals to minus 1, we can just put an NA over there. Okay, so not applicable. Okay, let's see for when x is equals to 5, right? When x is equals to 5, we'll have the square root of 5 squared, okay? And that's minus 5. 5 squared is 25. 25 minus 5 is going to be 20. That's greater than 0, so that's fine. Okay, let's just check the right hand side. Okay, so the right hand side, we have 2 roots x. So what happens when x is equals to 5? Okay, we know that this one is equals to the square root of 20. Square root of 20, right? So for the right hand side, you can do this on your calculator, actually, it's fine. When x is equals to 5, we'll have 2 times the root of 5. Okay, we can put this 2 back into the square root because it came out, because it's a perfect square, right? It came from 4. So this was originally, right? This was originally 2 squared times 5 inside of the square root sign. Okay, and now when you simplify on the inside, this is 4 times 5, and 4 times 5 is 20. Okay, so when x is equals to 5, the left hand side is equals to the right hand side, and 5 does not result in a negative underneath the square root in both situations, so this is going to be our solution over here. Okay, so we can even say, therefore, x is equals to 5 only. Just for curiosity's sake, that first question, did I solve for x or did I just factorize? I think I just factorized. Okay, let me just redo that first question again. I have a feeling I just factorized over here. 1.1.1. Sorry. X squared plus 9x plus 14 is equals to 0. We said that we're going to use x plus 2, x plus 7 is equals to 0. Did I do the step where I say x plus 2 is equals to 0, therefore x is equals to minus 2, or x plus 7 is equals to 0, therefore x is equals to minus 7? If I didn't do this step, Teffo, I am so sorry, but here it is. Don't make that mistake, right? Where you are asked to solve for x and then you just stop here in the factorizing step, right? I have a feeling I did not go there. I didn't do this part over here. Okay, just add it. So for question 1.2, we have to solve for x and y. So this is the simultaneous equations that I was talking about yesterday, right? And the two equations that we are given, okay? So we are given 3x minus y is equals to 4, and we have x squared plus 2xy minus y squared is equals to minus 2. Okay, right, so the way that we're going to approach solving these type of equations is that you need to see which substitution can you make, which is going to be the best option. Okay, obviously when you look at substituting for x, right, from here, it's not going to be such a nice thing to do, because then if you solve this for x, you're going to have some sort of equation that's going to be divided by 3, right? But if you solve this for y, okay, then you can immediately take that y and substitute it in here. Okay, you see you have a nice y that is isolated in the second equation, right? So you can substitute y there, you can substitute the y there, then you'll form an equation that is just in terms of x, right? And that equation is most likely going to be a trinomial that you're going to form. Okay, so let's do it, right? So you're given this and you're given that, right? We already stated that we're going to substitute into the second one, so let's just call this one equation 2, right? And then for this one, we'll rearrange it so you can use these arrows like this. This means implies or equivalent to, right? So if you solve this for y, you'll have y will go to the side and the 4 will come this side. Okay, so you have y is equal to 3x minus 4. Okay, I'm going to call this our equation number 1, right? So you have to lay it out nicely for the person who's going to be marking your solution by stating to them which one is equation number 1, which one is equation number 2, and what are you actually doing. Okay, so we are going to say we're going to substitute now. So we just write SUB, sub, right? We're going to substitute equation number 1 into equation number 2. Okay, then you go on and you do that substitution. So you have x squared plus 2x, and in place of y, we're now going to write 3x minus 4. Okay, and then we're going to have minus y is now 3x minus 4, and that quantity is squared, and all of this is equals to minus 2. Right, so now we can just simplify, right? For our simplification, we just need to check what are we dealing with, right? So we're dealing with a binomial over here, and it's squared, so we have to be careful about that. And then over here, we're just dealing with a term that's on the outside that has to distribute into this bracket. Okay, right, so let's go. So we'll have x squared, right, plus 6x squared minus 8x, and we'll have this minus. Let's put a square bracket because we still need to expand this out. This negative will still have to distribute into the bracket, so let's put a square bracket over here, right? And then for this distribution, what we're going to have, let me not use a square bracket. Why am I being fancy? A round bracket is also fine. Okay. So for this expansion, we're just going to have 9x squared, right? Then we have positive times negative is a negative. 4 times 3 is 12. 12 times 2 is 24. And that times x. And then lastly, minus 4 squared is going to be a positive 16. Then all of this is still equals to minus 2. Right. So now we have to deal with this negative, right? And we now need to distribute it to all of these terms over here. Okay. Okay, so we're going to have x squared plus 6x squared minus 8x minus 9x squared plus 24x minus 16 is equals to minus 2. Right, so now we just need to collect like terms. Right, so we have an x squared term, we have another x squared term, there's another one. Right, and we also have x terms, right? So we have this x term, we have that x term, right? And then we have constant terms, right? So we have this minus 6 and this minus 2, right? This minus 2, we're just going to evaluate it by just moving it to the left hand side. So it's essentially just a plus 2. Okay, so what do we have? We've got x squared plus 6x squared. That gives us 7x squared, right? And then we need to minus from that 9x squared, which means that we have minus 2x squared, right? And then for the x's, we have 24x minus 8x, right? That's going to leave us with a positive 16x, right? And then lastly, we have a negative 16. We're going to add to it 2, right? So that's going to leave us with minus 14. And all of this must equal 0. Okay, so from here, right, we can take out a common factor of 2, right? Always try to recognize that common factor. Let's actually take out the true common factor, which is a common factor of negative 2, right? And that will leave us with x squared, right? And then over here, we'll have negative 8x. And then we'll have a positive 7. And this is all equals to 0. Okay, we can now divide both sides by negative 2. The negative 2's will cancel, right? Over here we'll just have a 0. And we're still left with the trinomial x squared minus 8x plus 7 is equals to 0. We can use 1 and 7 to get to 8, right? We need a negative 8. So negative 1, negative 7 will be a negative 8, and negative times negative with positive, so that's fine. So we'll have x minus 1, x minus 7, and all of this is equals to 0. Okay, so then therefore x minus 1 is equals to 0, or x minus 7 is equals to 0. Lastly, we're going to have x is equals to 1 or x is equals to 7. Okay, now remember what we're doing right now. Okay, we're solving a simultaneous equation. Okay, we just come from solving trinomials, right? Just pure trinomials, and a trinomial was embedded inside over here. Okay, so don't now make the mistake of just stopping at finding the x value. Okay, so for solving the trinomial separately, it's fine. You get your x value, that's done. You move on with life. Okay. With the simultaneous equations, after getting your x value, you need to go back and get your y value, right? Because remember, we're solving for x and y. Okay. So it's a very common mistake to find kids stop their solutions over here because we are so used to just calculating for the value of x, right? So whenever we see values of x, I don't know, our mind sort of tells us that we've reached the end of the solution, but always be a bit careful. Go back to the question and just remind yourself, what are you actually doing? Okay, so we now have two values of x, right? We have an equation that can calculate y for us. That's 3x minus 4. So we can now just say, right, so this was our first step over here. Substitute 1 into equation 2. So now our next step, we want to tell our marker, right, that what we're doing now is we are substituting the x values, right, into equation 1. Okay, and when we do that, we're going to have the case when x is equals to 1 and when x is equals to 7. Okay, y is defined as 3x. Is it minus 4? Yes, minus 4. Okay, and that will give us, that's going to be a 3. 3 minus 4 is a negative 1. Okay, and then we have, for the second part, we'll have y is equals to 3 times 7. That's going to be 21. And then we need to minus 4 from that. Okay, so 20 minus 4 is 16. 16 plus 1 is 17. Okay, question 1.3. Right, so for question 1.3, we are given a function. Right, so given f of x is equals to x squared plus 8x plus 16. Okay. Question 1.3.1, right, we need to solve for x if f of x is greater than 0, right? This is an inequality. Okay, so basically what we are trying to do here is to solve for x when f of x, which is actually x squared plus 8x plus 16, we want to know when is this strictly greater than 0. Okay, so we want to know when is this function positive. Okay, and on the graph, that literally just corresponds to when is this function above the x-axis. Okay, so we can solve this two ways, right? So the first method is just to solve the inequality, right? The second method is to solve this using the sketch of this function. Okay, so let's go for method number 1. So when we solve the inequality, we'll have x squared plus 8x plus 16, that must be greater than 0. The very nice thing about this trinomial is that it's a perfect square, right? So this is square and this is a perfect square. I'll just rewrite it for you so you can see. So this is x squared plus 8x plus 4 squared, right? We want to know when this is greater than 0, right? So you can see you have perfect squares as your first term and your last term, right? Remember I said that when you have this case, right, we didn't look at this case a lot in our revision, but then when you have this case of a trinomial, and this factorizes very nicely, okay, into a binomial squared, and this is greater than 0, right? We want to know when is this greater than 0. And the way that it factorizes so nicely is that you just take this x, you drop this sign, and you take that 4. Okay, so inside this bracket, you're just going to have x plus 4. That's it. Okay. If you want to, you can write it as 2 brackets, right? X plus 4, x plus 4. It's really up to you. Now from here, right, notice that what we have over here is an inequality, right? This is an inequality sign, it's not an equal sign. Okay, so we're not going to carry on here by square rooting both sides, right? That's not going to be the next step. Okay, if it was an equation, yes, we could square root both sides, but because it's an inequality, we're not going to square root both sides because then we're going to lose one of our solutions. Okay, so what we do now is we find our critical point. Okay, And our critical point is going to come from setting this, right, equals to 0, or setting your two brackets x plus 4 equals to 0. But you can see that if you write it as two brackets x plus 4, setting either of those two brackets equals to 0, you'll find that your critical point is at minus 4, either way. Okay. What do we do with the critical point? We put it on the number line. Okay. And it's just there, minus 4, right? And you would have x plus 4 and x plus 4, right? And you would substitute your test values into both brackets, or you can just get an overall sign like immediately and just substitute into x plus 4 all squared. Okay, so x plus 4 all squared. Okay, and recognize that if you're going to be substituting into x plus 4 all squared, you're going to get your regions of positive and negative immediately. Okay, so you're not going to need to go negative times negative and then get your overall sign. Okay, so let's test. Right, let's use negative 6 this side and let's use 0 on this side. Okay, so if you substitute negative 6 in here, right, you'll have negative 6 plus 4, right, and that will give you a negative 2, right, but negative 2 squared is something positive, it's a positive 4, so this whole region is a region of positivity. Okay, what about 0? When you substitute 0 in there, you'll have 0 plus 4, okay? That's going to be 4, and 4 squared is a positive, okay? So both of these regions are regions of positivity, okay? So then we can then say, therefore, right, this, okay, x squared plus 2x plus 16 is greater than or equal to 0 when ever x, right, is less than 4. Okay, so for this region over here, from this x value of 4, right, so sorry, from this x value of negative 4, right, we're not including negative 4 this time because we don't have an equal sign, we're just looking for strictly greater than 0, right? So basically we're looking at this section and we're looking at this section. Okay, so we just have a gap in our solution. The only thing we're not taking is this negative 4, right? So our answer is therefore x less than negative 4, or when x is strictly greater than negative 4. Okay, if you want to write this in interval notation, just by the way, when you write your answers, okay, it's either you write them in inequality form like that, or you write it in interval notation. There's no need to write both. Okay, I'm just giving you both of them so that you can see the different notations. You use the one that you are comfortable with. Okay, so if you are comfortable giving the answer like this, then just give it like that and move on with life. If you want to give your answer in interval notation, give your answer in interval notation and move on with life. Okay, so for interval notation, remember I said that what we are doing when we are writing our solution in interval notation is that we're coming in from the left-hand side. Okay, we always come in from the left-hand side. And as we are coming in, we are recording our solution, right? And in this case, if you come in from the left-hand side, you're going to see that, okay, you're coming in from negative infinity. When you get to this negative 4, that's not included, so you have to skip this, right? So you're going to have round brackets, negative infinity, until you get to that negative 4, and you're not going to include it, so it's still a round bracket, together with the next solution set, which is after this negative 4. As you carry on, you're looking at values greater than negative 4 all the way up to infinity. Okay, so from there, it's negative 4 all the way up to infinity, and infinity is never included. Okay, so that's one way to state your solution. That's another way to state your solution. Okay, so this was solving for x over here, right? Using the first method, which is to solve the inequality. Okay, so we solve the inequality, Your other method that you could have used if you wanted to is to just draw a quick sketch, right? And by quick sketch, I just mean a quick sketch of the parabola, right? Now, please make sure that you are just doing a nice quick sketch, right? So sketch of graph. And I'm one to give advice, right, about drawing quick sketches. I'm a very big hypocrite when it comes to that, because I like to make things too perfect, right? But then in question number 1, I also try to just restrict myself, because with question number 1, you shouldn't be spending too long on question 1, right? You must just breeze through question 1 at least in 20 minutes or even 12 minutes if you can, and then move on with the rest of the question, right? So when we are solving this inequality using the sketch of the parabola, what we're just trying to capture is the x-intercepts, right? And maybe the y-intercept if you want to just have a clearer idea of what's going on, okay? So where are you going to get that information? Well, you get that information from here, right? So from this equation, you already know that this is your y-intercept. I don't really care about the value right now. I just care about the fact that it's cutting the y-axis on the positive side, right? So on positive 16 means on the positive side. And then for method 2, right, you would basically still go through this part, right? So you'd still go through this step, you'd still go through this step, and you would still go through this step of finding your critical point. Because remember that your critical point at the end of the day on your graph, that's just your x-intercept, right? So this over here is your x-intercept. So if you're using method 2, all of these steps, right? So all of these steps you would do, and then instead of drawing the number line to get your areas of positivity and negativity, right, you would draw your sketch, right? So method 2, the number line is just replaced with a sketch. So let's draw a sketch. And we just know we have only one x-intercept, so which means that the parabola needs to touch, right, or be tangential to the x-axis. So it has to look something like this. Okay, and this is definitely not to scale, but we're just capturing the properties of the parabola. Okay, and the only thing I'm going to show is that this is minus 4, that point over there. Okay, so now you can immediately see that with your original inequality, right, you are trying to evaluate where this parabola is greater than 0 or just where it's above the x-axis. And you can also remember that from here, right, f of x is y. So if y is greater than 0, it means that y is positive. Okay, so this is where y is positive. So this is where y is positive. All of this, okay, all of this is the side where y is positive. And obviously on the other side, this is where y is negative. Okay, so all of this. Okay, so now you are looking for where the graph is above the x-axis, and this is where the graph is above the x-axis. It's above the x-axis here and here. Right, and you can see you get the same solution as above. Right, so it's all of these x values, excluding this one, and then all of these x values. So that's how you use the number line, and that's how you use the sketch. Okay, so for question 1.3.2, right, we are asked, we are still in the situation where we are given this f of x, right, so we are given x squared plus 8x plus 16, right. Now we need to determine for which values of p will f of x equal to p have two unequal negative roots. Okay, so what we're going to focus on right now is these key facts, right? Two unequal roots. Okay, we'll skip that negative. We'll use it maybe at the end to interpret our solution, but this is just basically an application of nature of roots, right? So if you have two roots, right, those roots are obviously going to be unequal. They're just over describing over here. This situation is just basically that we need to set our discriminant greater than 0, okay? Because that's going to give us two real roots. Okay, so what's happening over here, right? You're taking this f of x, right, and you are creating a new graph, right? You're creating a new trinomial by setting it equals to some value p, right? So let's try to visualize this, right? So f of x is x squared plus 8x plus 16, right? And we want to make this equals to some value p, right? This value p is going to be some number, right? So if for example, it was minus 2, right? You can see that this minus 2 can move to the left-hand side, and it's going to be a plus 2. Then you'll have 16 plus 2, which is going to be 18, right? So this is going to be your new graph, right? So if this is your new graph and you're setting it equals to 0, you're basically finding out where this new function has its x-intercept, right? So now we want to find out what values of p can we use, right? What range of p values can we use such that the new graph that we create is going to have basically two x-intercepts, right? We want to have its discriminant greater than 0. Okay, so we can't use this value 2, we have to use a value p, but we basically going to be solving this the same way. Okay, we're going to move that p to the left hand side. Okay, so here's the p, right? So we are going to rearrange this to x squared plus 8x plus 16 minus p is equal to 0, right? From there, because we are just concerned about the discriminants, we're going to pull out our a, b, and c values, right? So a is 1, that comes from there. B is 8. And c this time is going to be 16 minus p, right? This is our new c. Okay, you can even write here. You can use their description or you can use that. Let's use their description. Okay, so for two unequal roots, right, set the discriminant greater than 0, right? So let's go. What's the discriminant? The discriminant is b squared minus 4ac. We want to know when is that greater than 0. Substituting in our values, we have 8 squared minus 4 times a is 1 times c is 16 minus p. And we want to know when is this expression going to be positive, right? Okay, so let's just simplify this left-hand side so that we can see what we're doing. Okay, so we have 8 squared, right? And then we have minus 4 times 1 is going to be 4. And that 4 needs to be multiplied into 16 minus p. That's still greater than 0, right? So what I'm going to do is I'm going to distribute this negative 4. Okay, these negatives, you must be careful with them. They like to catch you. Okay, so I'm going to distribute this negative 4 into this bracket. Okay. So that will give me 8 squared minus 4 times 16 basically. And then negative times negative is going to be a positive 4p. We want to know when is this greater than 0, right? I'm not actually sure what is 16 times 4. Let's just see. Okay, so 4 times 16, that's 64. And I actually do know that a squared is 64. So I know that this is 64 minus 64 plus 4p. When is this greater than 0? This is now a very easy equation to solve. The 64's cancel each other out, leaving us with just 4p greater than 0. Dividing both sides by 4 won't change the inequality, but if this 4 was negative, then the inequality sign would have to change direction. Okay, but since it's just positive, this is just therefore whenever p is greater than 0, right? So you can choose any p value that you want, right? Any p value that's positive, right? Then this equation here that you'll set up, right? When you move that p to the left hand side and you set it equals to 0, you'll be determining the x-intercepts of that new quadratic, right? It's going to be a different graph to f of x, right? And apparently, according to them, they are saying that when you actually find those x-intercepts, right, given that you've chosen p greater than 0, right, that graph is going to have two negative x-intercepts always, right? So for whatever p value greater than 0, your graph is always going to have x-intercepts in the negative side, right? So it's going to look something like this. Right, so that brings us to the end of today's video. Teffo, I wish you the best of luck as you continue with your journey practicing these type of questions, and also just with your overall journey in mathematics, right? If you do need any other extra assistance, well, you already know how to get into contact with me, so we'll talk soon. For now, it's goodbye from me.